Hello everybody! In today's lesson we're going to be talking about SOHCAHTOA and the 6 trig functions, including how to use Pythagorean's theorem to find some of these. Alright, let's get started. So there are 6 trig functions that we're going to be talking about. You might only be aware of the 3 that you saw in geometry. So it was sine, cosine, and tangent. And in Algebra 2, we're going to be talking about the next 3. And so the reciprocals of these functions. So we have cosecant, we have secant, and cotangent. Ooh, misspelled. Erase that. Let's start that again. Cotangent. All right. You will be using an angle and labeling the rest of your triangle in reference to the angle that we're going to be labeling. And we are going to label the sides opposite, adjacent, and hypotenuse. Okay? So before we do this though, let's talk about the 6 trig functions. So sine has a relationship of opposite side divided by the hypotenuse side. Cosine has the adjacent side divided by the hypotenuse side. And tangent is the opposite side divided by adjacent side. And then we have the reciprocals. So sine and cosecant are reciprocals, which means that cosecant is hypotenuse over opposite, which is the reciprocal of the sine. You can see the fraction has flipped. And then secant is going to be the reciprocal of cosine, so it is going to be hypotenuse divided by the adjacent side. And then cotangent will be the reciprocal of tangent, so it would be adjacent divided by the opposite side. Alright, so we're going to be referring back to this a lot. Now, the reason we talk about SOHCAHTOA is because in geometry, for this sine, cosine, and tangent abbreviations, we would say things like SO, S-O-H. So that's tells us that sine is opposite over hypotenuse. CA, C-A-H. So it's SOHCAH, and then we have the TOA, T-O-A. And this is an abbreviation we use to kind of remember the relationship between sine and the sides. All right, so let's look back. Steps for today. We're going to circle the angle that you want to be the reference angle. If you change where your reference angle is, remember that the sides also change. We'll talk about that. If you're missing any side lengths, you have to use Pythagorean's theorem to find it, like we did yesterday. And then we're going to label the sides opposite, adjacent, and hypotenuse sides, and then use SOHCAHTOA to find the ratio of fractions. Okay? Now, we're not going to have to do all of these steps all the time, but we are going to make sure that we have everything that we need. Okay, so let's look at it. It looks like for the first one, everything is labeled A, B, C. We have all the sides, so we don't have to run through Pythagorean's theorem. All we have to do is pick a reference angle. Now, the way I know which one is my reference angle is by the angle that they keep telling me. So here they're saying angle A, angle A, angle A, angle A. So I'm going to have to go ahead and look at everything from angle A. So that's going to be my angle. Now I circled it for you, but I'm just going to erase it and just kind of put an arc there. Okay, so that's where I'm looking at it from, which means that my hypotenuse is still 5. Oh, sorry. Opposite is going to be 3, so this will be my opposite side. And adjacent is the last side that we have not labeled. It means next to. But hypotenuse gets a special name because it's across from the 90. All right, so once we have those labeled, now we just go ahead and do sine. Now sine is opposite over hypotenuse, so the fraction is going to be 3 divided by 5. Cosine is adjacent over hypotenuse, so it will be 4 over 5. And tangent is opposite over adjacent. 3 over 4. And then we know that these are the reciprocals, so we're going to just go ahead and flip them. This will be 5 over 3, 5 over 4, and 4 over 3. I do double check, make sure they match correctly before I just assume that it is correct and in order. Okay, so that's what we have to do today. All right, we have a couple more examples. Every time getting a little bit more challenging. All right, so let's look at this. Now, example 2, we are working with angle B. I can see B, 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 B. Okay, so I'm going to put my angle right there. The problem with this one is I don't know one of the missing sides. So I'm actually missing side B. So what we're going to do is right underneath the triangle, we're going to run the Pythagorean theorem. And before we do, let's label some of the sides. So this side is A. This is one of the legs. And this is leg B, and this right here is our hypotenuse. Okay, that's C. So we're going to run the Pythagorean theorem. A squared plus B squared equals C squared. And we have 6 squared plus B squared, we don't know what it is, equals 10 squared. And then we're going to solve for B. So 6 squared is 6 times 6, which is 36. And we have 10 squared is 10 times 10, which is 100. We're going to go ahead and subtract 36 to the other side. And we get B squared equals 64. We're going to square root, and we get B equals 8. So that's our missing side. Now I'm going to go ahead and just erase the leg parts at least. And so I know this missing side is 8 now. And I'm going to label I left the hypotenuse because hypotenuse is always hypotenuse, but I am going to label the other sides opposite and adjacent now. So opposite of angle B is 8, so this side is my opposite. And adjacent to angle B, next to it, is 6. Okay. All right, so now we're going to go ahead and use what we know. So we have SOHCAHTOA, just to kind of help us out if you ever forget. But you can always go back to the other page too and see. So we need opposite and hypotenuse for sine. So we have 8 and 10. So we're going to do 8 over 10. And we do have to reduce if we can. So this would be 4 over 5. And then for cosine, it's adjacent over hypotenuse. So adjacent is 6. Hypotenuse is 10. So 6 over 10. And we're going to simplify that to 3 over 5. And then tangent is opposite over adjacent, so 8 over 6. And that also reduces to 4 over 3. And then cosecants are just the flips. Now I am going to take the simplified version. So this will be 5 over 4. Cosine and secant are reciprocals, so 5 over 3. And tangent and cotangent, so I'm going to take that and flip it 3 over 4. And those are our 6 trig functions with their fractions. All right, let's look at the last example we have. Now, theta is a Greek letter. We use it to represent an angle. So instead of A, B, and C using those letters at times, we'll use the theta symbol. So don't get scared. It just represents that angle right in that corner. Now, what's nice about this triangle is, once again, we have all of the sides. One of the sides is a square root, but that's not a big deal to us. So all we have to do is label. So if this is the angle I'm looking at everything from, 5 is my opposite side because it is across from me. Now, across from the 90 is always the hypotenuse, so that's going to be my hypotenuse, which means that the only one I haven't labeled is my adjacent. I always leave my adjacent to the last labeling because I feel like that's the hardest one. All right, so we're going to go ahead and do SOHCAHTOA again. Sine, so sine is opposite and hypotenuse, so that's 5 over square root of 61. Okay, and then we have cosine, we have adjacent and hypotenuse, so we're going to do 6 over square root of 61. And then we have tangent, opposite and adjacent, so we have 5 over 6. And then we're going to do the reciprocals. So this is square root of 61 over 5. And we have square root of 61 over 6. and 6 over 5. Now, your teacher might ask, especially for the ones for sine and cosine, since we have a square root in the denominator, your teacher might ask you to simplify that more by multiplying top and bottom by square root of 61. And so you would get 5 times square root of 61 over 61. That would be a rationalized answer. And you might have to do the same thing for the cosine. You get 6 square root of 61 over 61. Okay, so you might be asked to do that. The other ones we don't have to worry about because the square roots are in the numerator. It's only when it's in the denominator we might have to take a couple steps further. All right, good job in today's lesson. I will see you in class.